And now, dear students, we are going to talk about a very important idea concerning the sum and the product of roots. So as you know, the roots are x prime and x double prime. In case delta is positive, there are two distinct real roots. S is denoted, the sum is denoted by the capital letter S, and product is denoted by the uppercase P. So S is the sum of the roots, that is x prime plus x double prime, and its formula is minus b over a. So S is equal to minus b over a, and P, the product, is x prime dot x double prime, and its formula is c over a. Now, where do these formulas come from? Let's see the proof. X prime plus x double prime is minus b plus radical delta over 2a. If you remember, x prime is minus b plus radical delta over 2a, and x double prime is minus b minus radical delta over 2a. Now, since they have the same denominator, I can directly add the numerators. Now, minus b with minus b is minus 2b, and plus radical delta will cancel minus radical delta because they are opposites, and all what we get is minus 2b over 2a. Canceling 2 together, we will get minus b. So 2 and 2 are cancelled, then we will get minus b over a, and thus the sum is equal to minus b over a. That's proved. Now let's prove why is p equals c over a. Let's see here, x prime dot x double prime minus b plus radical delta over 2a is for x prime dot minus b minus radical delta over 2a for x double prime. Now we have to multiply the numerators together and the denominators together. Now the numerators are, after applying the difference of two squares, we can directly square minus b squared to get b squared, and minus radical delta squared to get radical delta squared will give delta. And the denominators multiplied together will be 4a squared. Now let's substitute delta, because we get b squared minus delta over 4a squared, then it is b squared minus, this is delta, b squared minus 4ac over 4a squared. Now introducing the minus sign, b squared is going to cancel b squared, minus into minus 4ac will be 4ac over 4a squared. Now simplifying 4 with 4, a with a squared, what remains in the denominator is a, and thus the answer is c over a, and that's why the product is equal to c over a. Here is an example to let us know how to benefit from the sum and the product idea. Consider the equation E that's equal to 3x squared minus 7x plus 2 equals to 0. Verify that E has two distinct real roots. What does that mean? Let's remember. Does a quadratic equation has two distinct real roots when its delta is positive, greater than 0. So we have to prove that delta is greater than 0. Now verify that 2 is a root of E. We have to verify that 2 is a root. How to verify a root? We just evaluate in place of x, and we have to get 0. And deduce the other root, or find the second root using S or P. Let's start. A equals 3, B equals minus 7, and C equals 2. Then delta is, applying b squared minus 4ac, is minus 7 squared, which is 49, minus 4 into 3 into 2, which is minus 24. Then the answer is 25. So delta is 25, which is positive. Then surely this equation has two distinct real roots. Now to verify that 2 is a root, as I told you, we just evaluate x by 2. So 3 into 2 squared, or 2 into 2, whatever, minus 7 into 2 plus 2. So we can put 3 into 2 squared. Okay. True, because 3 into 4 is 12. Minus 14, here is minus 14. So 12 minus 14 is minus 2, and plus 2 is, it is 0. Then 2 is a root of the equation E. Now I have one root, suppose it is x prime. How to use S to find the other root? I know that x prime plus x double prime is the sum. And applying this rule, x prime plus x double prime is minus b over a. I have b and I have a. So substituting x prime by 2 plus x double prime and then writing minus b over a in its value, which is minus 7, then 7 over a, then 3. Then this is x prime, which is calculated here, which is verified here that it is a root, it is 2, plus the other root, which is x double prime, is equal to the sum. And the sum is equal to minus b over a. And minus b over a is from the equation 7 over 3. Thus, definitely, x double prime is 7 over 3 minus 2, which is finally 1 over 3. So, if we are going to use the product now, so we can either use the sum or the product. X prime equals 2. And x double prime is the missing one. So 2 times x double prime is equal to the product, which is equal, using the rule, to c over a. So 2x double prime, because x prime is 2 and x double prime is the unknown, is equal to c over a, which is 2 over 3. Then x double prime is 2 over 3 over 2, which is definitely 1 over 3 as the previous result here. Let's see also where do we benefit in exercises from the sum and the product idea. Where do we use the sum and the product? If x prime and x double prime are the roots of an equation E, that's equal ax squared plus bx plus c as in general for the quadratic equation, then the equation E is written as x squared minus sx plus p equals to 0. This is a rule where s is the sum and p is the product. So x squared minus sx plus p equals to 0, where s is x prime plus x double prime and p is x prime plus x double prime. Let's make the proof. Where did this come from? If x prime and x double prime are roots, then x minus x prime and x minus x double prime are factors. Okay? Equals to 0. Now let's expand. We will get x squared minus x into x double prime minus x into x prime plus x prime x double prime equals 0. Now let's take x common, so we will get x squared minus x. What remains inside is x double prime, and here is the sum appearing, plus x prime. So I just take x as a common factor. What remains inside is x double prime plus x prime plus x prime dot x double prime equals to 0. And thus x squared is for the variable x minus, you notice, x prime plus x double prime, or x double prime plus x prime is definitely s, so minus sx plus p equals to 0. And this is where the rule comes from. So we are going to use this rule in order to form quadratic equations in order to calculate the roots. Here is another example in another way. We have to write the quadratic equation whose roots are 3 and minus 4. Then the roots are represented by x prime and x double prime. So I can get the sum using the sum of these two roots. 3 plus minus 4 is minus 1. And I can get the product which is 3 into minus 4, which is minus 12. Then applying this rule, x squared minus sx plus b equals 0, I can form the quadratic equation. So x squared is kept, minus sx, then minus into minus 1 is going to be plus 1x, plus b means plus minus 12, which is minus 12, and this is the quadratic equation that's formed by knowing the sum and the product of the roots. Another example. The first root here is radical 2 plus 1, and the second root is radical 2 minus 1. Then I have to use this equation, this form, to find the quadratic equation. So I have to find the sum and I have to find the product. The sum is radical 2 plus 1 plus radical 2 minus 1. I can cancel the opposites, 1 and minus 1, to get 2 radical 2. So the sum is 2 radical 2. Now the product, using the method of difference of two squares, radical 2 times radical 2 is 2 minus 1, then 2 minus 1 is 1. So the product is 1 and the sum is 2 radical 2. Thus the quadratic equation is x squared minus the sum into x, so minus 2 radical 2 x plus b. So don't forget, minus the sum into x plus b. So minus before s and the plus before